Good morning, John. So nice to have you here today for the masterclass about reducing the scope 1 and scope 2 emissions for the industry of manufacturing. Today, John, we are going to talk about how we can reduce our scope 1 and scope 2 emissions within the purview of using technological options. We'll discuss the barriers and drivers as well, and we'll also touch upon what kind of engineering solutions currently exist which are causing the scope 1 and scope 2 emission reductions. Finally, the most important part would be the reporting of scope 1 and scope 2 emissions, because no reduction or impact can be done if we are not measuring it. Let's start with defining what the scope 1 and scope 2 emissions are.
Yeah, sure, I can take that. So the first thing, I suppose, to simplify it, Abhinav, would be to look at, direct emissions versus indirect emissions. So to kind of talk about scope 1 being that direct emissions, that's something that you consume or a consumable that you operate on site, or so that could be like part of your process emissions, could be a fuel that you're using to make steam or something like that, so gas. There are kind of emissions that are taking place directly on site. That's counted as your scope 1, whereas scope 2 is referred to as electricity or steam maybe bought over the fence, as we would call it traditionally. So it's generated off-site through consumables off-site, but is then transferred to your site to be used on site. So kind of the easiest way for most people to think is fuel like gas or biomass I'm burning on site is my scope 1, and then electricity or steam, if I'm purchasing it, would be scope 2.
Yes, that's absolutely right, John. And I think this segregation is the fundamental when tackling the reduction part. Once we have bucketed our emissions in these categories, it helps us reduce and target them more effectively. And this is where the significance of the scopes come into a global environmental protocol. Now moving on to the technological options that exist for reducing scope 1 emissions. Some of these innovative or not so innovative technologies would be, the first one would be the enhancement of existing process efficiencies. These are the low hanging fruits and the low capex involved projects that we can look at, starting with how we are using the energy as of day, and is there a capability within us, is there an opportunity that exists to reduce that energy usage. The second one, John,
Yeah, sure. It would be maybe like alternative fuels that have a less of a carbon impact. You're looking at biomass, LPG, bio LPG, hydrogen. You're looking at fuels that have a low carbon element to them, and you're consuming them on site. I suppose a negative towards them is their logistics and the space they require, storage and regulations around them, whereas the good part about them is maybe they can fit into your own combustion train. If you're still using steam on site, you can still burn the fuel to generate that steam. You don't have to change your manufacturing. So while they are very, very good fuels, they do have barriers and they do have advantages when it comes to fuel source and different types.
Yes, like anything, they do have their pros and cons, and it's up to the site to decide which is their priority and where they can compromise a bit on. Finally, I would say the electrification of heat processes is a huge innovative technology that is coming into that's coming around in the few years, as and more we can see that more renewables getting integrated into the grid. We can see that utilizing heat pumps, we can offset our carbon emissions by a huge factor.
Yeah, definitely. You touched on it there, Abhinav, around heat pumps. The nature of a heat pump as an alternative to a combustion source. So just say if you have a traditional boiler, you put in fuel, you have an efficiency. So the fuel you put in, you don't get 100% of that as useful energy. You actually only get maybe, depending on the type of the combustion train or the delivery of the heat, 70, 80, 90% of that energy. So what you buy is you don't even get the full value, as opposed to a heat pump, where you're looking at where you put in one piece of energy, you may be getting 4 to 5 times out in delivered heat. So from that point of view, as a pure energy requirement to deliver your operations, it's a great thing to reduce energy. As we'll see later on in the masterclass, there's barriers around that, because maybe the cost of electricity versus the thermal fuel that you're using maybe not in a commercial favour. But from a pure energy point of view, heat pumps allow for that. And again, heat pumps, maybe some people might be not sure out there, are, they're refrigeration systems in their purest sense. They're a long established, very reliable type of technology. It's about making sure it's applied in the right way. The design for the utilisation of the heat source and heat sink is done correctly, and they can be a very effective tool in the electrification of heat and allowing companies to decarbonise their operations in really large chunks.
Yes, agreed. And we might not be there when it comes to completely replacing the high temperature requirements with heat pumps, but still there is huge use case scenarios for heat pumps which can be in just stepping up the heat. Let's just think about preheating boiler water or such that.
You can make a great point there. Steam generation heat pump technology, while it's out there in its prototype state, it's definitely not widespread or kind of muchly deployed type of technology yet. It's in its early stages. Hopefully, in the battle against our carbon emissions, it's going to be a key player going forward. But it's maybe not mature in its development yet. So, but that's not to say that heat pumps are higher temperature in the maybe 80, 90 degrees Celsius can't be used in your existing systems to maybe preheat or save energy or steam or heat directly from combustion gases. It's definitely a tool that can get you a step along the way while waiting for that technology to be developed and become more widespread. Definitely.
Perfect. And moving on to the scope 2 reduction using technology, the first thing that pops into mind is the use of solar panels, wind turbines, and on-site renewable installations. Here we are seeing increasing incentives by the government as well to provide us financial benefits, and this can be a viable source of generating renewables and reducing our scope 2 emissions.
Indeed, I suppose the major thing to discuss when you talk about renewables on site or either through a PPA, they're green in their sense, so they're very, very carbon friendly and have that footprint, but they're an enabler to affect the spark ratio or gap, so the cost between your existing thermal fuel versus that generation, or your current, grid cost. So, if you look at the technologies, the main thing here is what's your current cost of delivered of heat versus what would it be through an electrification of heat. If your cost of electricity is high, that's going to be a big problem to help you to do that. These are great tools in the toolbox to be able to implement some of the renewable energy like solar or wind to help bring down that cost, to bring the ratio of the cost of gas or thermal biomass, whatever it may be, closer to your cost of electricity, so you can kind of allow you to go look at electrification of heat technologies and deploy them with a commercial value and a return on your investment going forward.
Yes, absolutely. And another approach could be having long-term PPA contracts with renewable energy clauses in them, so that there is a guaranteed reduction in your scope 2 emissions, and you don't have to invest or rely on renewables on site, and you don't have that hassle of maintenance as well.
Yeah, space being a key thing here. Maybe you have a roof that's not capable to support solar, you don't have much operational area for planning, maybe could be a problem with like a wind turbine. So there is other routes, and there's lots of market there, or companies in the market there that are providing that service to maybe provide a off-site development or an off-site source of these renewable energies, but you can then get the benefits of them
Yes.
appropriately. And I guess the other thing to say around these renewable energy technologies, and purchasing green energy, it's a huge way to reduce Scope 1 in a broad brush stroke. You can change drastically your profile quickly by purchasing some of these PPAs and moving to a huge carbon reduction for your operations, if that's what your requirement in the near term or short term is.
Another innovative solution would be the use of batteries and thermal storage to mitigate this renewable intermittency, because as and more we are having renewables on the grid, and the fact that renewables are not that constant in nature, there are times when we have got more electricity on the grid that we are not using. So using technologies such as batteries as a storage mechanism, or heat as a storage mechanism, heating up materials to a certain extent and utilizing that heat later on, could be an great storage solution as well to reduce Scope 1 emissions.
Yeah, indeed. I suppose from my job and my day role or day-to-day role, more where this comes into the like of thermal storage is understanding heat sources and heat sinks, understanding the operations of the site. Can you charge a heat sink or source by artificially creating one to be able to use the energy later on in the day or during operations? They are key kind of things to be able to do, again, along with the other technologies, as we were saying, either through a heat pump or through your solar, which obviously only works during the day. Maybe you charge up a large storage of heat or whatever it may be. So you have to be creative and understanding of these the good parts of what they are, but they are limited, that they have to be implemented in the right strategy within the operations of the site to be able to yield value. There's no point in putting in solar panels if your peak load or your load on site doesn't make use of the energy. Yes. That kind of thing. You have to have that understanding of when the energy is being used on site, where is it being used, and then you can employ the right solution when it comes to technology to address that.
Yes, absolutely. Now, coming to the barriers and drivers for the Scope 1 emissions and Scope 2 emissions. One of the biggest barriers, I feel, is the technological constraints that we are currently having. There is a limit both in terms of supply chain, in terms of using the standardization that we see that are posing as a challenge. What are your thoughts, John, about that?
Yeah, the standardization of some of these solutions, because they're newer technologies and a newer way of operation. Sites are maybe using hot water versus steam, but steam was always being used. So you have operators or you have systems and you have mechanisms that were designed around the original piece of technology, and then it's a barrier to move away from that. But again, I suppose that's the decarbonisation challenge, and that's what we're here to do and help our clients to do, is to be able to bridge that gap with innovative solutions or clever solutions to be able to, jump that barrier to allow them to use these types of technology. I suppose, as I was referring to previously around steam heat pumps, while they're not available in a smaller, just say a commercial or light industrial state, there is mechanical vapor recreation technology. Yes. There is the opportunity to generate steam through electricity at maybe a larger or a heavy industrial scale. Yeah. So hopefully some of those aspects of the design, and as I said, as maturing of maybe a commercial box heat pump that you can buy, will become available. That will help bridge that barrier. But indeed, it is a barrier that yes, companies are going to have to face and come up with solutions to do. And I suppose that's what we're here to support, and why we're giving this masterclass.
The second biggest barrier, John, I feel, is the financial and economic one. There are still instances where it is cheaper to use energy powered by non-renewables, and this is not generating that proper incentive yet. and we can see on the other side of the coin the fact that there is that initial capital expenditure that is required when we are switching over to renewables, and then there is an increased operational cost and the complexity that is coming with this investment. So there is this dilemma still existing where a person has to
Sure.
choose whether they continue with their existing use of non-renewables or take that drastic step to change over to
Yeah,
renewable.
yeah, definitely. To kind of to row in with that, like, you know, the inherent, as I touched on, the spark gap is a key thing. So the cost of your power, whatever that may be, electricity generally, you know, in the electrification of heat element, you know, if that is significantly more expensive than your thermal source of energy, that's a big problem that you have to try jump with your solution. Then there's the issue, I suppose. Again, this is not new. Carbon is just a new influence or a new impact of capex deployment strategy. You know, energy projects have been on the go for a long time now. Obviously, as energy prices go up and they become more important. But you know, looking at capital investment, return on an operational cost is a key thing that companies have to do anyway, day to day. Carbon is just becoming another influencing factor. So can I get a return on investment for my project? Can I get a carbon saving as well? And maybe putting a value on the return on investment towards that carbon is what people are doing now to try help to make that financial case for these solutions. But that ratio between the cost, like I said, of electricity and your thermal source of energy is a key thing that you're going to have to address, no different than what it was in the past, when maybe just energy savings was the key driver. Carbon now is another player in that assessment.
Yes, absolutely. Finally, I would say policy and regulation, we are still facing difficulties in implementing, say, renewables when it is related to a geography, or there is a way where the supply chain is affected because of the complex regulations that are going on in importing this renewables. Also, the raw materials as such for producing these renewables, there is a huge difficulty in transporting them, the way they are being extracted from the earth. So there is a huge area which needs to be addressed regarding the policy and regulations, and there is this uncertain environment, legislatively speaking, about how we are tightening our carbon emissions year on year, and how it will change as we go forward. Finally, John, I think we should address the other side of the coin, that is the drivers for the emission reduction initiatives. And the first thing that comes into this is the regulatory incentives that the governments are coming up with, be it carbon pricing mechanisms, emission trading schemes, or tax benefits. I think all three and more of them are a very good incentive that are offsetting and giving a good return on investment for the companies. And not to forget the fact that when we are implementing these procedures and renewables, we are in essence creating a market competitiveness, both in terms of reducing our costs through the reduction of energy, and also creating an image as a corporation that we are concerned about the environment, we are taking the right steps to go towards that reduction of carbon.
Yeah, it's very important for companies out there at the moment to be, sustainable. I think everybody now wants to do the best they can for the environment. So, as a company, you're going to try also to demonstrate that. So there is mechanisms out there and drivers to help you. The market is aware, customers are aware. Obviously, still, price is a key part, quality is a key part, but sustainability is becoming more and more important in the consumer's thoughts. And I don't think that trend is not going to decrease, it's going to increase. And you putting yourself as a company in the right place is going to maybe get you to get a step on your competitor. And it is important to understand it. And I guess anybody tuning in today will be there, are tuning in because of that. They're aware of the need to be in a sustainable approach and going forward further, not only just for the company, but also meeting their goals, that the targets for their 2050, be it carbon zero or on such.
Yes, and not only the consumers, the investors as well are more concerned about where and how companies are tackling their ESG and scope 1, scope 2 emissions. We have seen of late big investment firms such as BlackRock explicitly stating that they will be going forward, they will be choosing companies who have a better plan and strategy for their emission reductions and ESG. We also are seeing an increasing trend of funds which are tracking companies through ESG methodologies. This brings us to the next part of our discussion, John, would be the engineering advances that we are seeing towards the direct emission reduction, that is the scope 1 emission. And the first thing that pops into my head is the process optimization. Just like the lean manufacturing principles, the big thing that comes into picture here is the fact that using a software, an energy management system, not unlike our CoolPlanet OS, which is tracking and measuring your data in real time and giving you insights on how you can reduce your energy usage and emissions. It is imperative that we get a hold on that data that is lying around and start extracting insights and opportunities from it.
Indeed, the age-old battle of, monitoring something in a timely manner, energy that's been and gone and wasted, it's, that's not much use to you. You need to be some way in a timely manner to be able to understand the influencing factors, why it was wasted or why it was consumed, how it was consumed, and then be able to make an action to, okay, we can fault find to try stop that the next time it's going to happen. So that's definitely the element of real time, or getting to a more timely manner of response about your data. Then I suppose, as you alluded to there, the like of a software like CPOS, decarbonizing software, you can then bring in more streams of information. You look at your logistics, you look at your energy, you look at your production, you look at your operation of your utilities, and it's combining that data together through clever insights and understanding that you really can see the performance and the energy consumption, where it is, what the influencing factors are, that you can do something about it, either that through developing projects or developing ideas and concepts to improve it, whether it's infrastructural changes or equipment changes, or just by good practice, behavioural stuff. Yes. All are done. You need that data, you need that understanding to be able to make those decisions. So using, not just having a software, but having a useful software that's bringing in all of those aspects is the key. A lot of people can have an energy metering and monitoring system, which is creating graphs and trends, but is it actively doing something? And even better, preactive or predetermine what's going to happen. And even, to touch again more on that data, is the modeling potentially, maybe like the likes of a digital twin or something, that allows you to be able to almost predict when something's going to happen. And that's what we're trying to do, and that's what these types of softwares allow you to do.
Yes, and acting up on those predictions as well. That brings us to the advanced control systems. The response and setting up set points and alarms is also very important. Once that data is almost live, then we have got that opportunity to act upon any deviations that are going on.
Yeah,
Yeah,
definitely. You probably see that more in your day-to-day job. But again, I
yeah,
think if we, as we look at here at the slides, you know, 1 and 2 definitely are the same coin. It's just two
same,
sides of the same
same coin.
coin. You need to be doing both. One without the other is not
Yes.
really that valuable. They need to be done in a combination to get true value from it. Yeah.
Advanced control systems are imperative, as we can see, and it will help in optimizing consumption and minimizing waste. Going to holistic design, engineering design, John, what is your take on that?
Holistic engineering design is kind of my day job. It's part of the day work I do here at CoolPlanet from a day-to-day point of view with the solutions design team. I suppose to kind of try explain our approach, which we feel is a good approach. It's about the first principle element of design. You know, having that on-site presence, going to site in occasion to understand what the physical operations are of the site, what its restrictions and challenges are, and then bringing that, incorporating that into the solutions so they're tailored to fit that specific requirement from a operations, location, infrastructure point of view, as well as the commercial setting. You know, different locations and different places of the world or different operations have different barriers to cost on their spark ratio or whatever it may be.
Yeah.
So understanding that is first the key part to then move on, and then, you know, around larger projects, you know, to deliver them in a savvy manner. That's where our expertise comes in. So you know, maybe you've some
Yes,
points there.
absolutely. I agree that even though the biggest project might not be the first one, however, the smaller projects are geared in such a way that it is the bigger project is kept in a view, keeping that in the view, and it is the small incremental steps that we can take, the smaller projects that take us to the big carbon emission reduction project. Uh, Absolutely, I agree with you on that fact. The step by step deployment is extremely important.
Yeah, you know, you could take an example like a boiler, for example. You know, maybe the spark ratio, the commercial ratio doesn't allow you to go to a direct electrification of heat, but there's an element of heat recovery that could be done. You can implement that heat recovery with a hot water loop.
Yeah.
You're obviously reducing the energy or the consumption of gas or whatever it may be for the boiler. But the good news is if you design that hot water loop in the correct manner, that's perfectly the infrastructure you need for a heat pump going forward. So you know, designing with your forward-looking decarbonisation end goal is a key thing, and I think that's what we do very good within our team, bringing in the expertise of many different departments or peoples. So within our team, we'll have process, we'll have utilities experts, you have a process modeler. You know, you have all that understanding brought together as a team to kind of trash out the best idea and best solution, not just for the immediate requirement, but, you know, with that longer term goal or longer term idea that maybe that can allow you to hit your long-term goal, your long-term carbon reduction goal. But in the meantime, you have smaller targets to hit, but, you know, they need to be met. Maybe a more traditional project allows you to do that, but you always design it with the idea of the big step change or whatever it may be, to a different heat pump technology or whatever it may be. The site is able to work within for its operations.
Let's discuss about some of the engineering solutions for indirect emissions, John. And the first thing is the use of smart grid technologies, and we can see now increasingly the grid is becoming dependent on renewable sources of electricity. Here, I feel that this is a good thing and a bad thing, because with the increased use of renewables, there is a huge instability in the grid. However, the regulations are addressing this and they are providing incentives where financial incentives. If and when there is a reduction in the demand or there is an increase in the demand, the companies are getting paid to switch off non-critical equipment and have a flexible mindset and help the grid transition into a more renewable sources of electricity.
Yeah, the balance in the grid is a key challenge. I think that everybody needs to be aware of. Industry, domestic users, everybody has a part to play within the grid, especially within countries or areas where the grid is very, very already at its capacity. You must be able to balance it, and you know, the grid is there for everybody. It's the key source. It's going to be a key player in the decarbonisation of operations or for industry, but in domestic case as well, with heat pumps and electric car charging or whatever it may be. So we all need to be aware of what we can do, whether it's simply, you know, like the advert is lately is saying, like, turn your washing machine on when it's windy
Yes.
outside or whatever it is. We can all, it's important to make small changes, but industry is no different. Its operations has to be aware, understanding of the challenges of the grid, how it's going to impact their designs and solutions for their operations, and how they play their part in the grid, because we all rely on it to work together. So you can't go rogue and and just have your own ability or your own thoughts on it. You have to be able to understand that it's a shared resource, that your designs, from our point of view when we're looking at designs, that you can accommodate capacity on grids for heat pumps or whatever it may be, electrification of heat. It's a key consideration in our designs. You know, what is the local grid capacity? Can the client get access to that power? Because it's a key issue, definitely.
Yeah. Another unique way of approaching the Scope 2 emission reduction is the ISO 50001 framework, which develops a culture within the organization that is geared towards continuous improvement. Just analyzing what their baseline energy consumption is and setting up realistic year-on-year targets and approaching that targets in a realistic manner creates a very nice environment where the manufacturing industries are continuously trying to reduce their energy consumption and their carbon reductions. It involves a huge part from metering, collecting the data points, and identifying opportunities from those insights from that data, and tracking ENPIs, KPIs, and ensuring that we are always going towards that path of net zero. Finally, I think if we are to reduce our carbon and energy consumption, carbon emissions and energy consumption, it is key that we know how we are tracking those things. And this is where the reporting comes into picture. With regulations such as CSDR coming into picture, I think it is key that people know, the manufacturing industries know what their KPIs are, what are they using to track their emissions. Is it realistic enough? Is it truly reflective of your carbon emissions?
Yeah, sure. To kind of weigh in there a little bit, from my point of view, you know, some facilities have so many KPI. They might have an overall arching KPI, but you know, within each SKU or product, within each operation, you know, how well are they able to define the energy performance of a material, or how much energy is being invested into making a product versus the next product? You know, that's a big challenge, and I don't know if industry is fully there. Certain industries are fully there yet, but it's a gap that they're going to have to close. And where I see it, or what I'm thinking is, you know, to be able to do a full Scope 1 and Scope 2 analysis of your operations on site, you need to have an understanding of each SKU, each KPI, each department, and be able to measure and quantify carbon stripped out for each thing. Because without another masterclass for another day, when it comes to Scope 3, your scope 1 and scope 2 becomes your client's scope 3, or vice versa. It becomes scope. If you're supplying, you become their incoming, or if you're a product, developing a product that they're buying, that's going to be added to their scope 3. So if you can't accurately define and understand your own scope 1 and scope 2, it's a big barrier going forward around industry trying to track scope 3. So getting that accuracy is key, understanding all of your consumables, your materials, where they're coming from, and then how much energy you're using to develop them, or your operations with them. It is a big trend, or a big change towards that maybe people are not used to. It generally was energy was tracked from a cost point of view, but now it doesn't matter really about actually how many units of energy. It doesn't matter about that. It does matter about the cost, but the next thing that's influenced it is carbon. Potentially you maybe will even want to take an operational hit for a serious carbon reduction. That's how serious carbon needs to be taken going forward, I guess.
And just wanted to touch upon, if we are getting the data, then there are different data collection strategies. We have seen an increasing shift in trends from the good old days of manual data collection to an advanced IoT sensor type of technologies, and it is helping manufacturing industries track their KPIs in a much more real-time way, in a much more dependable manner as well. And there are energy management softwares which are catering to this data, and CPOS, a perfect example for this, is it is technology agnostic. It can ingest data from various sources, and it can analyze it and provide insights in a very user-friendly manner.
Yeah, agreed. It's going to be a key tool for myself as a solution design engineer. One of the key tools that we will be using, and people going forward using, will be data software that's given you that KPI, that's given you the understanding of the utilities, production. Part of the best way for the design of a project, or to optimize carbon energy operations going forward, is a data-led approach in the design. Maybe whereas historically you would take a first principle approach from what you were required to do, but here now it's given an extra layer of complexity and understanding of what's actually happening on site, and you're using that data first, as we said, to kind of go back and summarize the start, reduce your energy, optimize your operations first, and then you're making sure you're designing your decarbonisation solution for what's required, rather than a phantom or something like that, an inefficiency that's already built into the system that then you design for, which makes your design more inefficient. You want to get away from that, and I suppose a data-led, accurate software that's giving you that information is a key aspect of that.
Yes.
Yeah, definitely. From our point of view, also it helps with speed. So the timely manner of understanding and getting the project and bringing it towards project delivery, the like of a tool like CPOS allows for that, because you have the element of measurement and verification. You can prove the project, you can calculate the savings up front very, very easily, and demonstrate to the financial requirements that are commercial. You can put that commercial case forward, whereas maybe traditionally it takes longer to make that case for a project. That's another part of the software too. It allows you to maybe expedite or speed up the process of delivering projects, which is another key thing for people probably tuned into the masterclass today. Is a requirement. Is that speed. You have a 2025 target, you have a 2030 target. How are we going to get there quickly? The software is going to allow you to be able to do that in a more timely manner.
Yes, absolutely. If you are trying to justify the capital expenditure for any project that you have, the real-time MNV is a great tool. Also, models create the perfect platform where you can showcase that whatever project that you have implemented, how it is performing over the period of time, and what savings we are creating as we go forward. And thank you so much, John. Just summing up everything that we discussed today, we started with defining the scope 1 and scope 2 emissions, and trying to discuss the innovative technologies from the process efficiencies and the electrification to electrification of heat processes. Uh, and then we touched upon how renewable integration can reduce scope 2 emissions. Finally, we also discussed barriers and drivers to emission reduction, which constitute of technology, financial, and regulations and policy. The engineering advances that are currently going on for reducing emissions, which is important for you to have your data, ingest that data and derive insights from it. Finally, the use of culture and the grid to reduce your scope 2 emissions is also a huge factor in reducing carbon emissions. The reporting standards and how we can report it, and what is the importance of those reporting standards in reducing scope 1 and scope 2 emissions is also been touched upon. Thank you so much, John. And if all of our viewers, if you have any questions, please feel free to reach out at the following email ID.
Thank you.
Thank you.
Thank you.